Yes, not negative. That was not for Kobe.
So if we want to do one quick correction, we can do this again.
Yeah. All right. Derivatives of trig inverses. Mr. Stankowski, Mr. Crow, take a seat. Stop showing Jack something.
I'm showing Jack
An Eli TikTok. Okay. All right, we are going to write the 6 derivatives for our trig inverses. If you don't remember what a trig inverse is, that's inverse sine. Sine, it looks like sine to the -1. But another name for that, are you ready, is arc sine. Arc sine, sine to the -1, those are just the same exact meaning. Arc sine of u, we're going to call it. Arc sine u. The derivative of arc sine u is u prime over square root of 1 minus u squared. And if you want to find out how that's been derived, you know, go ahead and look it up yourself. I don't have time for this. All right. The derivative of arc cosine. And by the way, the worksheet I give you will have all of these on it. They actually just write it a little bit differently. Is negative u prime.
Sorry. You want that on the back of that?
Front. Over square root of 1 minus u squared. So again, what does that mean? Well, if this was like 5x, you would take the derivative of that, which is, and you'd put -5 and then put 5x right here and then square it. That's all it means. This is your u. You always do the derivative of what's after the word sine, right? Isn't that what we normally do, unless we have it squared or something? Yeah. Arctan is u prime over 1 plus u squared. Now again, I'm not going to make you memorize all these. If you're part of the SBCC crowd, though, it is a post. You're supposed to have it memorized. Am I going to let you? I don't know. Haven't decided quite yet. Derivative of arc cosecant is negative u prime over the absolute value of u times square root of u squared minus 1. Yeah, that's right. Derivative of arc secant u is u prime over the absolute value of u squared minus 1.
Why did they write it so confusing?
How is it confusing? It's a formula.
Okay, well, I understand what looks the point of this.
What does that even say? Is that absolute of u?
Oh yeah, what happened to my u?
11.
11? Absolute value of u. There we go. Thank you. Over 1 plus u squared.
What I'm saying is, like, if you see this and you're like a random person, you're like, what the heck?
I know, but isn't that the beauty of mathematics? And then you're like, and then you know what you're doing. It's the same I tell the stats kids, because the stats kids have all these crazy formulas, but it really just is so simple in plugging in. All right, I've got five examples, one of which is on the worksheet that you'll be doing tonight. Pretty simple. I'm going to keep this all simple tonight because really my SBCC people are the ones who have to do it hard. Everybody else, you just need to know how to do it like simply. All right, so let's take the derivative of, let's just do an easy one. And notice again how I've changed it. I've changed it now to sine. It looks like sine to a -1. But really, what is sine to the -1? It's really just arc sine. That's what they are. They're the same exact. Well, why did they change it? Why do we? I don't know. I'm not the guy that invented it. I just teach it. Ay, ay, ay. All right, this is your u. What's your u prime then? 3x squared. You follow the formula then. The formula says u prime. Oh, 3x squared. Over square root 1 minus your u squared. My u is x cubed, but I'm going to square it. What does that make? Ooh, this is where we had a problem in the other class. X to the 6th or x to the 5th?
6.
Correct. Power to power, you multiply. I know. It's good to... why can you not do anything and factor this out? Like, why couldn't you just take the square root of 1 and call it 1 and square root of x to the 6 call it x? Because it's a binomial, y'all. You cannot take it out unless you have one of exactly the same thing. Binomials are tricky when you have those things. If it was a monomial, yes, you could pull it out, but you can't if it's a binomial. All right? Know your algebra skills. That's it. Now, do I want you to rationalize? No. There are some people that do want you to rationalize. I think it looks messier if you rationalize. Don't you think so? Because this would go up top and it just looks messier to me. So leave it like that. Easy, breezy, beautiful. Let's move. d dx of inverse cosine of 5x minus 9. d dx is take a derivative. See if you can do it. Okay, this is your u. Usually whatever is after cosine, sine, whatever, inverse. Take the derivative is 5. Follow the formula. Derivative of arc cosine is negative u prime. So the negative of that, which would be negative 5, over the square root of 1 minus 5x minus 9, the whole quantity squared. Now, am I going to make you FOIL it out? No. I know. I hope your algebra skills, you could FOIL that out, but I think that's fine. Again, if we're plugging in an actual value if we were trying to find the slope, it wouldn't make sense for you to actually FOIL it out. That would be like another x squared and another x rather than this right here, squaring it. Although coming to find out yesterday's quiz, I was kind of annoyed with some of you, how you don't know what this is.
Well, negative sine x squared, of course.
If I said negative sine squared x is, yes, and you're all like, yeah, this is sine x, you put it like this.
Oh my.
No. I was very angry. Very angry about that one when I was grading things. All right, almost done. Let me do this one, another one, and then I'll do one for miracles. So inverse tan of square root of x. Obviously, again, this is your u. I would call it x to the 1/2. Your derivative would be 1/2 x to the negative 1/2, but I would rewrite this as a fraction. This would be 1 over what? 2, and I would actually call it root x, okay? Because you kind of, if it's a 1/2, just do root x. Okay, then follow your formula. The derivative for arctan is u prime, which would be 1 over 2 root x, over 1 plus your u, which is x to the 1/2, squared. What happens when you square x to the 1/2? What does it become? Just becomes x to the 1, right? So you have 1 over 2 root x over 1 plus x. How do you get this, though, to be one fraction? Because you should never... Yeah, same change flip. Just another way, because I think, again, y'all don't know manipulations well, and I'm trying to show it to you. But if you have this, you could just multiply the top by that denominator and multiply the bottom by that denominator. And these will cancel, and you have 1 over 2 root x times 1 plus x. Don't FOIL it out. Don't rationalize it. Some teachers will want you to. Again, I think it gets messier. You multiply the top and bottom by square root of x. It's not in the mood, but did y'all follow that pattern? Okay, but yeah, same change flips, whatever. All right, I think I got one more and then one of your homework problems and we're done. Oh yeah, I want to show you this one because this is the absolute value ones.
All day long.
Jed, you got a shout out from Judy yesterday.
I know, that was lit. I didn't even know you knew my name.
That was really cute because he was looking for Bryce, and he's like, "Oh, hey, Jed."
Yes, it's fine though. Bryce is good.
He loves Bryce. Bryce, wrestler and football player. All right, so my u is x to the 4th. My u prime is 4x cubed. I'm going pretty fast through this because, again, this is just formula. If you follow the formula for secant, let me just look at it again. It would be u prime, so 4x cubed, over the absolute value, I'm not going to write those absolute values just yet, but the absolute value of your u, which is x to the 4th, times the square root of your u squared. So what would that actually be? X to the 8th minus 1. Are you allowed, yes or no, to cancel my boy Jed?
No.
Except you are.
Oh, because it's only one, yeah.
Yeah, this is a monomial. This is a monomial. I think he meant no for here. You are correct in this position.
Yeah, I wasn't talking about the outside.
Okay. So you can actually cancel an absolute value because the absolute value of it is positive. So it would be 4 over x, which is in absolute value, times the square root of x to the 8th minus 1. That is actually a more simplified, better version to write that I would like you to write for that one. Jack?
What if the U was like negative?
What if the u is...
It's still
Yeah, because it's an even. You're squaring it. All right, and then this is actually question number 4 on your homework tonight. I'm doing it because this is a little bit more challenging. This is a little bit more like what my SBCCers are going to have to do. But you know what? Let's see if you all can do it too. And don't just stop me like, oh, I'm not taking that class, so I'm not going to do it. You know, that'll just make me angry. You know that, okay? You know it. Y equals x times inverse sine of x plus square root of 1 minus x squared. I think this is what you had a big problem with on when we did a harder derivative worksheet. You just, when you have a plus, you take each derivative separately. You work them separately. So we're going to work this one separately, and then we'll do this one separately. Okay? So this is product rule.
Oh.
So we have to do first x. Yeah.
So the plus root is not part of the sine?
Not at all. No. Mm-mm. So first times the derivative of inverse sine x would just be, let me look at my thing, would just be the derivative of this. What's the derivative of x? 1 over square root of 1 minus your u x squared. Okay, so that's the first times derivative of the second plus, we're still not done because we're doing product rule. Second, leave it like that. Yes, leave it like that. Times the derivative of the first. What's the derivative of x? 1. Okay, this right here is just the derivative of that. By the way, I couldn't tell you how many people forgot yesterday how to do product rule with sine and cosine when they were next to each other. I was very angry at some of you. The derivative of sine is cosine, derivative of cosine is negative sine, and that's my answer. No, it's a product rule. When I grade papers, it's very bad. I yell at you all, and then thank goodness I don't know your name until I flip it back over. Then I'm really angry at you. All right, now let's do this one. Let me do this one over on this side. Anybody know how to take the derivative of this, what this entails?
Negative 1/2.
It is a chain. What's your u?
1 minus x squared.
Or no, 1 minus x squared.
Right. This is 1 minus x squared. The derivative of that would be, okay. I go to rewrite this problem. This would be u or square root of u or u to the 1/2. You all agree? And then if you take the derivative of that, how do you take the derivative of u to the 1/2? 1/2 u to the negative 1/2 times the chain. Okay, if you're like, I don't know, I don't remember how to do it, go look in your notes. We've done the same exact one before. Okay, I've just attached it to something new that you've learned. All right, now let's replace this u stuff inside here. Again, don't worry about anything else right now. Just replace this inside here. So let's see what I would have. 1/2 times 1 minus x squared to the negative 1/2 times the chain negative 2x. Okay. Can you clean that up for me anymore?
Negative x.
Yeah, negative x. And then where does that go? Yeah, over what?
Root 1.
Root 1 minus x squared. Oh, that's interesting. Here's why.
Oh, no.
This,
They cancel.
he's back, y'all. He's back. This and this, if you multiply that x, where does that x go? To the top or the bottom? Top. These two are opposites. And what's going to happen to them is they cancel.
Bye-bye.
And your final answer is inverse sine of x. That's the derivative of that. All that? Yes. And if you're kind of sad that you didn't join us in SPCC, right there. Right there. Actually, I take that back. This is level B for her.
Why did the X and the 1 cancel?
They don't cancel X times, okay. All right. Let me give you our worksheet and talk you through, because I know what you're about to say. The same class, I said it in the other class. They were like, what is it? Because everybody writes it differently. Mrs. Seta just wrote it differently than the way it is. What are the boxes? Can I see your paper? I'm just really blind. Yeah, you can also come. I would never make you closer. I know. What are the boxes? I'm waiting for that one. Just take the paper. I think I froze it.
Let's put X in there.
Right, not X, but U. Yeah. Okay. So if you just put a U here, and then you put your U here, and then it's du dx. Du dx, y'all, we've talked about this before, is just another way of saying U prime. That's all it is. Well, why'd they put it on the side? Well, that's the same as if you multiplied it to the top by 1. It's just, and if you ask me questions like this, I kind of get a little, I do get a little probably testy, because these are all algebra skills that you should know. But this is just U prime over the square root of 1 minus U squared, okay? So we just did this one right here. We did number 4. So 1 through 7 is brand new. By the way, 7 is multiple choice. Do you realize that? It's not, do I do A and then I do B and then I do, no, you just figure this out and choose if it's A, B, C, or D, or E, okay? And then 8 through 15 is a little bit of all the derivatives that we have been exposed to. For example, you should know how to take the derivative of 8 right now very easily. And if you don't, that's sad. Okay, you should know how to take that derivative. This one, you're going to have to do a what? Quotient rule. Cotangent, you have a derivative of that. You have the derivative of cotangent. This one is product rule. This is why I love this worksheet. By the way, if you don't like theta, you can call it x. This is just x squared. Okay, and this is tan squared. Remember, you need to rewrite this as tan of 3 minus x squared, the whole thing squared. That's going to be a fun derivative. ln, oh yes, my SPCCers know their ln's. That's what they just took a quiz on. This is a product rule, and this is a chain rule. All right, I want to see this done. I haven't decided if I'm going to grade this one. I might grade 2, because that's fun for me, but I don't want you to not do this. I did send the answers. Did you get that little key already? All right. So look at the answers, and then that's it. That's all you have to do today. The rest of the time is yours to get this done. That's homework. The whole